Hello, everybody. This is the last or next to last lesson in Chapter 9. I am going to talk about doing significance tests and the possibility of making mistakes or errors called type 1 and type 2 errors. Because after all of our conclusions that we write, they're all based on probability, the probability of obtaining a sample. And because of that, there's the possibility that we are making a conclusion, but it is indeed the wrong conclusion, perhaps. So let me get into that here. Let me just start by defining them. There are three different vocab words this lesson. One is a type 1 error, a type 2 error, and the PAWA. A type 1 error is alpha. So we've seen that before. It occurs when you reject HO, which we do often, but HO is actually true. In plain English, this is a false alarm. The alarm went off, but there was no fire. Or it would be like the boy who cried wolf. He screams, "Everyone come, there's a wolf. I'm about to get attacked." But everyone runs out, but there's no wolf. In probability notation, this is the probability of rejecting HO given, HO, given HO is actually true. That's not good. The probability of a type 1 error is actually just simple. It's just alpha. Um, And well, because we'll talk about that more. A type 2 error is beta. It occurs when you fail to reject HO, but HO is actually false. In plain English, this is a missed detection. Okay, the house is burning down, but the fire alarm didn't go off. It missed it. Um, HO was false, but we didn't catch it. Okay, that's a type 2 error. In probability notation, this is the probability of failing to reject. I think the probability notation helps. Given that HA is true. That's another way of saying HO is actually false, right? If HO is false, that means HA is true. The probability of a type 2 error, again, is beta. Just definitions. Now, power is 1 minus beta, you can see right there. It is the probability of correctly rejecting a false null, a false HO. Probability notation would be probability of rejecting HO. You reject it, and you should have, meaning given that HA is true. Okay? This little box here helps me keep track of these things. So three of these boxes are here. Okay, type 1 error, type 2 error, and PAWA. So here we go. Well, so we've got the reality, and then we've got our conclusion, right? This is what we concluded over here, and then reality over here. So if you reject HO, but HO is true, that is this. That is a type 1 error. So I'll say type 1 error. This is alpha. Okay. Where does type 2 error go? Type 2 is when you don't reject HO, but HA is actually true. Isn't that another way of saying HO is false? The reality is HO is false. So I don't reject HO, so it's this box, okay? This is a type 2 error. You'll often see this as like two Roman numerals instead of the number two. Um, okay, and this is beta. So where does power go? Power is when you rejected a false null. You rejected HO and HA was true. That's this box right here. Okay, so this is the power box, which the probability is 1 minus beta. This last box, well, we don't have a vocab word for it, but let's just talk about it briefly. You don't reject HO, and HO is true. Well, I think this is good, right? This is okay or good, right? In other words, HO was true and we did not reject it. Cool. We did the right thing. Smiley face. Okay. Um, and I guess you could equally put a smiley face here. Those are the two good results, right? You don't reject it when it's true. That's good. Then you do reject the HO when it's false. These are good, these two boxes. Okay, what does this mean in real life? Give it context here. Consider these two HO and HA. One, the null is that the patient's healthy. The alternative is that they have cancer. Um, Describing a type 1 error and its consequences. So remember, a type 1 error is when you reject HO. So I'll write it in words. We reject HO, but HO is true. So what does that mean in context? The doctor tells the patient they have cancer, but they don't. This would be bad, right? So you rejected HO. The doctor said that's not true. The doctor told them this. You have cancer. What is the consequence? The patient will undergo a treatment, right? Chemotherapy or whatever it may be. Undergo unnecessary treatments. Need That's saying nothing about the mental and emotional stress of that. Unnecessary treatments. It's going to cost money and it's going to stress out the patient and the family. It's a bad situation. A type 2 error, describe what that is. So remember, that is when you fail to reject this, but you should have. So you fail to reject HO, but HA is true. So what does that mean? So you don't reject this, so you kind of put a check mark here, but this was the truth. So what does that mean in context? The doctor tells patient they are healthy. Tells them everything is fine, but they have cancer. What are the consequences? The cancer will go untreated. Obviously harming the patient. So you will have to do this on a test and the AP exam. You'll have to identify in context what is a type 1 error, what is a type 2 error, just like this, when they'll give you an HO and an HA. Okay? Um, so, sometimes also, this one's called a false positive test. and this one is sometimes called a false negative. I'm just trying to throw as many different thoughts at you to help you understand it, right? False positive is when you think the test was conclusive of this, but it's not. False negative is when you don't do anything, but you should have. Okay. Now the next half of this is to get you to understand the probabilities of these. What is the probability of a type 1 and a type 2 error, and what is the probability of the power? So here is a make-believe situation. We're going to say that the null is 100 and that the alternative hypothesis is that it's greater than 100. We're going to set alpha to 5%, sample size is 36, and the standard deviation of the is 12 of the population. So I sketched this on Desmos. You can actually do this too. You can put this into Desmos. It's a normal distribution centered at 100. Why is the standard deviation 2? This would be good memory. The standard deviation of a sample of 36 people or 36 items is sigma over root n, which is 12 over root 36 in this case. And that's 12 divided by 6, which is 2. So the math worked out actually pretty nicely. So the curve goes up by 2. This is 1 standard deviation. 104 would be 2 standard deviations, and so on. What I've done here is I've done this on Desmos, where this line is set to the location where this shaded region is 5%, and that cutoff line is 103.3. So that helps me to answer this fill in the blank question. At the 5% significance level, in other words, at that alpha, any sample above this line will result in rejecting the null hypothesis. Any sample above 103.3, I would reject HO. Now, higher up in the notes, it said the probability of a type 1 error, that is just alpha, right? Because if the truth is 100, if this is the truth, then 5% of the time will result in samples over here. We have to set this cutoff line somewhere. But no matter where we set it, we are going to make a mistake that often. So if I were to move this line back and say, you know what, I don't want to make a mistake 5% of the time, I want to move this line back to the spot where it's a 10% cutoff, well, that's fine. You're going to reject the null less often. Sorry, if you do this, you're going to reject the null more. So actually, you're going to make a type 1 error 10% of the time. If you move this line over here and say you set alpha to 1%, so I'm zooming in and you're going to say, I'm only going to reject for this little green section. Well, you're still going to be wrong 1% of the time, right? Because this is the probability of rejecting HO when HO is true. And this entire curve is set up under assuming HO is true. So anyway, anything above 103.3 and we will reject this and we'll go with this. All right, in Schoology, you can get to this, what I'm describing right now. I'll show you. Let me back up. Oops, I got to restart. Anyway, go into the lessons folder down here, and I've got a link for Desmos for type 1 and type 2 errors right there. And there it is. So the one I just showed you is, let me get rid of the blue one for a moment, if it lets me. Hello. It doesn't want to let me turn the blue one there. That red one is what I just showed you. And you can see right here, that's where I got the 103.3. Okay. Um, that's that curve. And then the other one is the blue curve. So you can load this up because it's somewhat dynamic. You can see you've got some sliders here to play with. What are we doing? What's the main idea here? Now let's assume that the true parameter is 104. So that's the blue one, right? So the red one is the null of 100. And the blue one is that the truth is actually 104. Okay? Um, and we're going to try to label the picture with where does the power go in this picture? Where does the type 1 error go? And where does the type 2 error go in this picture? Okay? Um, so I think the easy one to start with is where does the type 1 error go? Well, it's really just this curve right here. This 5% is the probability of a type 1 error. So I'm just going to label it's kind of this one right there. That is alpha, that is type 1 error. Okay. Um, the blue, what do you think this blue shaded area is? Is that power or is that the type 2 error? Well, what is power again? Power is rejecting the null when HA is true. Type 2 error is not rejecting the null when HA is true. But I want you to notice we're going to look at these two. Both of them are operating under what assumption? They're both operating under the given condition that the HA is true. So they're both going to operate under the assumption that the blue curve is the actual truth. Okay? So if HA is true, what percent of the time will you actually reject HO? That would be this blue section. Remember what we wrote here? Any sample above 103, that's that black line, will result in rejecting HO. So this blue section, this is the power. And that is, that's 1 minus beta. According to our little notes up here, right? 1 minus beta for power. Okay? Now, this is the blue part. So what's this? When HA is true, but you don't reject HO. Okay? That would be, it's in this picture. Where is that in this picture? On this double normal curve picture. So again, that's when the blue curve is the truth, but you didn't reject the red curve. So that would happen anytime your sample is less than 103. So let me get a new color out. It's going to be this. Okay, it would be this green section. This green section is a type 2 error, and it is beta. Okay. Notice the green and the blue are just two sides of the same normal curve. So this and this, they're complements. They have to add up to 100. So if the blue side was 60%, then the green side would be 40, right? If this was 10, this would be 90, and so on. So they're opposite sides of the same coin. So we've labeled them all. Let me then go into these what ifs down here, and I'm going to go back to actual Desmos and play with it a little bit. Filling in these blanks. So first of all, the type 1 error is alpha, and I think what helps you understand this is it is completely decided by the researcher. They control it, they set it to be whatever they want it to be, okay? It was this original one up here. They say, okay, if I move the line over here to the green line, I lowered my alpha to 1%. So I'm not going to reject HO very much. So I'm not going to make a type 1 error very much. So if you don't want to make a type 1 error, you just lower alpha. If you are okay with making a type 1 error, you can move the black line this way. If you move the black line this way, say it over here, your shaded region is growing. So your probability of a type 2 of a type 1 error is growing. Um, how about this? What happens if alpha gets bigger? What happens to the probability of a type 1 error? Well, I just kind of said that, right? If alpha gets bigger, you increase a type 1 error. Alpha is the probability of a type 1 error. If you increase alpha, what happens to the probability of a type 2 error? Hmm. Increasing alpha means the percentage gets bigger. It doesn't mean the black line goes that way. If you want to increase alpha, it's actually meaning you're going to take this black line and move it this way. It's not moving the curve, the blue curve, it's moving the black line that way. As I move the black line that way, what's going to happen to the green section? It's going to get smaller. So increasing alpha decreases the probability of a type 2 error. Um, and if the green section gets smaller, that means the blue section gets bigger. Let me show you on, um, I was going to go to Desmos. So increasing alpha, okay? Let me show you here on the, oh, it started over again. Okay, thanks for your patience. So there we have it. Notice I've made like sliders. Um, I did that there with an N so I can change the sample size. Right now the sample size is down here. It's 36, see that? And I can, this is kind of cool, I can just slide it over and the sample size is changing. Let me put it back to 36. Let me just type 36, there we go. Okay, and then for the blue curve, I put B. In the picture, I set B to 104. And so again, I'm saying if the null is wrong, if it's not the red curve, I'm saying it's the blue curve. Okay? Um, and what I just did on the notes, as I said, what if I increase alpha? Increasing alpha means that this is not going to be 5% on the red curve, right? What happens if I make it 10%? That would be increasing alpha. So if I do 10%, you see the red shading moved over and the number there is 102.6. Let me move this to so it matches to 102.6. Now that matches up. And then on the blue curve, what's the probability of getting a sample above 102.6? And there it's 75.8. If I go back to 103.3 for a second, that's what it was. You see it's 63%, and that was the power. If I now go to 102.6, the power went up to 75 or 76%. So I increased this to 10, and the power down here went up. Okay, so that answers this question. Um, um, it's in reverse of this. If you decrease alpha, the power will go down. I'll show you that here too. Okay, decreasing alpha. So how do I decrease alpha on this? Okay, decreasing alpha means you go back up here. Normally it's 5%, so if you want to decrease it, you go down to 1%. See that tiny little red shading? So to do that, I have to have a sample above 104.7. So watch what happens to this probability as I type in 104.7. It just dropped. It got cut in half. I know the black line is not in the right spot. I apologize if this is a little too clunky, but I'll move the black line. Okay. So by lowering it to a 1% red curve, the power went way down to 36%. Okay. Um, however, well, they'll stay there. However, what about if I go to the left of the blue? Remember, the left side of the blue is the probability of a type 2 error. it's now 63%. If you look right here, right? It's now 63%. So my power went down, but my type 2 error went up. Because remember, power and type 2 errors are complements, which is actually, I'll jump around a little bit. Power and type 2 errors are complements. They add up to 100. They're inversely related. As one goes down, the other goes up. Okay, what about sample size? What does increasing the sample size do? Um, what does it do to the power and type 2? So there is a slider on here. Oops, wrong button. There's a slider on here for sample size. Let me go back. I'm sorry, I'm jumping around. I'm going to go back to the original 5% so that it kind of matches up with the picture on the note. So there's that 103.3. Go to the right, and I'll change this back to 103.3. Now it matches the picture in your notes, right? Okay. This slider here lets you change sample size. It's pretty cool. And as you go whoop up and down, you can see the curves are getting taller or shorter, but the center is not moving. Okay, that makes sense. But let's say I increase sample size to 64. I'm going to just type it in then. Okay. Um, I like that. Why did I pick 64? Because the square root of 64 is 8. So I don't know, just so this calculation up here would be it would be 12 divided by 8, which is 1.5. But whatever, it doesn't really matter what you pick. So let's go up here now and just say, okay, if I go back to my red curve, notice the alpha's at 5%, and that means to get a sample that would reject the red curve, I would need 102.5 or greater. So I'm going to go down here on the blue curve and say, what's the probability of getting a 102.5 or greater? It's 84%. It was like 68%, I think. It was 103.3, right? Yeah, it was 68%. Now, I got to be above 102.5 in order to reject the red one and accept the blue one. So that is the power. Remember, the blue shaded area is the power, and it just went up. I went from a size of 36 to a 64. I made it bigger, right there, and it increased. No, wrong button. I'm all over the place. So a larger N increased the power, and that's good. You want good power. Remember, power is correctly rejecting the null. If you increase N, what happened to a type 2 error? Well, hey, remember, these two things are complements. So if the power went up, the type 2 error went down. So it decreased. Okay, so I encourage you to play around with this, right? So here I went up to a sample size of 64, and the area to the right here, was 84%. The area to the left, um, oh, I gotta change my black line. This will help you see it a little bit better. Okay, there you go. The area to the left of the black line, that's the probability of a type 2 error. And it's now like 15 or 16%. It was higher. You can see it in action without moving the black line, if I lower my sample size right here, using the slider. Oh, where'd my, come back. If I lower it, what happens to, what you really need to keep track of is actually not the black line, but where the red shading is. The red shading, you can see it, if I go back to 5% here on the top, it's at 103.7. So if I type 103.7, that got a whole lot bigger, 44%, instead of, it was like 16%. Okay. Um, one last idea. What if I take the blue curve and I move it away from the red curve? See this? Essentially and practically, what am I saying? I'm saying, what if the truth is further and further away from the null? What happens to these three things? Let me go back to my original sample size of 36, my 103.3, and whoops, 36. Put my line back at 103.3. So visually it looks right. Okay, so this is the original picture, right? What if I take my blue curve and I start moving it to the right? This is a great picture of what's happening to the power. This right here, right now, is the power. If I go to 105, the power went up to 80. If I go to 106, it goes up to 91. So this makes sense, right? The further the reality is from the null, you're much more likely to reject the null. So this makes a lot of sense, okay? And you can also see that, you see the left region of the blue curve? The blue curve that's left of the black line, as I move to the right, it's shrinking. And again, that area I'm referring to on the left of the blue is a type 2 error. So as I pull these apart, power goes up and the probability of a type 2 error goes down. So very conceptual today. I get that, but hopefully this picture, I think, is worth 1,000 words. That's all, folks. Goodbye.